Well, hello everyone. We'd like to begin our session on marine drafting. Thank you for showing up today. I'm pleased to say we have some 100 attendees registered for this session, and I believe around 60 are logged in already. So that's great. This is part of a ongoing series of webinars intended for our technical users. Each one is intended to introduce one of our new products, give a brief overview, and provide a demonstration, at which time you can also ask questions. I encourage you to ask questions. Use the way to ask questions is either to raise your hand using the GoToMeeting session or submitting them by text. We will have myself and others will be monitoring the question queue, and we'll get to them as we can. We'd like to maintain the flow of the presentations and the demonstrations, but we also want to ask your questions as they come in. After the session, please like to direct you to the Augie Marine Forum, where you can continue to ask questions, discuss related topics. We have technical support as well as product management do monitor the Augie Marine Forum and contribute to the discussions there. If you are a ShipConstructor subscriber, I encourage you to also submit your questions via your Nexus account. The goals of ShipConstructor Marine Drafting are to reduce rework. The reality of any project throughout its life cycle, as you know, there's changes throughout, and we want to propagate that throughout the project. The shorter project schedules are really causing crunching in between the initial design phases and the production, so we want to enable that aspect. However, the 3D design does continue to progress throughout the project, and we want to be able to propagate those changes back to the 2D drawings and between the 3D drawings. In particular, we want to generate those 2D drawings automatically from the 3D product model. We also want to be able to leverage the existing AutoCAD skills in order to facilitate the changes and propagate those back and forth between the 2D and the 3D models. Now, what is marine drafting? First and foremost, it begins with class approval drawings in the initial design phase, the concept phase really, but it also includes other aspects such as workshop drawings, 2D arrangement drawings, and other drawings requiring 2D details. Importantly, we want them to generate them in native DWG AutoCAD. These can be edited as well with native AutoCAD, and the drawings should remain associative to the 3D model. As changes occur, they can propagate between the 2D and the 3D drawings and models. Now, how is ShipConstructor Marine Drafting different? Well, the traditional approach is that the 2D class approval drawings are constructed, designed, approved completely separately and distinctly from the 3D detailed design. They're really disconnected from a programmatic and database point of view. A more modern approach would be to begin in the 3D detailed design space and automatically generate the 2D class approval drawings from those 3D designs. That's something we've heard clients want to see, and it also really facilitates shortening the overall project lifecycle. And ShipConstructor Marine Drafting is very much designed around that concept to reuse effort and reduce errors generated from the 3D model, create outputs in AutoCAD DWG, and to associatively link the 3D model with the 2D outputs, thus reducing effort, reducing errors, and reducing the overall project lifecycle time. Why does it matter? Well, basic design and production design is in the same tool. That's what we'd like to see, and that's what we're seeking out. The basic design, currently the 3D is mostly basic design and production design. What we want to do is incorporate the concept design and initial design right through to production, all within the same tool set and models. Some typical scenarios, use cases, the class approval drawings, I mentioned them before. Other areas where these 2D drawings can be useful are workshop drawings, hybrid drawings, outfitting arrangements, and 2D details in any drawing. And part of the deal here is to reduce the total hours, reduce the effort and changes, and check in the 3D earlier. I would like to say that in addition to the producing the 2D output, these are intelligent 2D outputs. So they take that 3D model and they are the intelligence behind the scenes will incorporate the right type of information into the 2D space from the 3D model. So it's a lot of intelligence behind the scenes. So anyway, I'd like to hand off and get down to the down and dirty. Hand off to Jason Patterson, who'd like to demonstrate the product. And Jason is one of our lead designers, product development, and has been with the company from the beginning. So take it away, Jason.
Well, hello everybody. Like Norm was saying, I'll demonstrate, essentially go through the process of using marine drafting and show you all the details of what marine drafting can do. Here I'll start off and just show you an example of the output. Again, we'll start with the navigator. And marine drafting primarily relies on output drawings. And output drawings are a generic production drawing that can be used for multiple purposes, like arrangement drawings. And you have a user-defined folder structure here you can define to organize your drawings as you choose. And now the marine drafting drawings are based off of these output drawings. So in this case, I've got a frame drawing that's a classification drawing that's derived from this UO2 unit drawing. And I'll go ahead and open that drawing up. And this drawing takes the information from that output drawing and generates a 2D view of AutoCAD objects from it. So you can use that output to actually see your actual production output from model space in a layout. Just a fairly large drawing here because it shows all the systems and the structure from a complete unit. One of the advantages of this drawing that you'll find is that different than the other production drawings where you have to load all the objects into the current drawing, these drawings use the production output as an X reference. And so saving and loading the drawings is actually much faster compared to, say, a pipe arrangement drawing. And now here, I'll zoom in and show you some of the details. So this is a generated output marine drafting drawing that I'll go through the steps and show you how it was created. And it's fairly simple, but some of the details here. So we have automatically generated weld symbols. So it's actually analyzing these plate parts and determining where the seams are located. We have a continuous symbol here to determine which way the relations of the plates that are running across the screen and in and out of the screen here. We also have stiffeners. So stiffeners as single line representation with end cut symbols. And we also have the cross-section of the stiffener indicating the throw direction and orientation of the stiffener and, of course, the stock profile, in this case, a bull flat. And then we also have other details that you can see down here where we've got stiffener flange lines, that represent, of course, the flange direction. In this case, it's going forward because this view is looking forward. And I can see details of how the bracket relates to those stiffeners. And these are some of the things that you really can't get in a regular production drawing. The hidden line solid view in an assembly drawing, for instance, would not show you this representation exactly. And I wouldn't have control of the individual elements like I do here. So if I go in here, I can actually pick on this, and then this is just a polyline in AutoCAD, and I can get the details on it. So I can actually see, okay, do I want to see, whoops, sorry, picked the wrong one. Go away. mispick there. So I click on properties, and I can see that this came from this part, so this standard part, what stock it is, which view it's associated with, and I can get information about it even though it's just an AutoCAD polyline. And of course I also have the labeling capabilities as well. And then we also have details like baseline and centerline as custom objects. And those are interesting elements that are used, can be used not only just in marine drafting, but in all of ShipConstructor. And these allow you to define lines of reference that contains information of locations of elements. So I can say, oh, well, do I want to say where the location for longitudinals are? Oh, look, it's in this case you can see the text is overlapping. Oh, well, I'd rather have it perpendicular. Oh, maybe I want to reduce the text height. So you have all those capabilities without having to do that stuff manually in a block or however you do it currently, and trust in the information that this is the actual locations of where those elements are. And now I'm just going to go through and show you the details of actually creating one of these drawings. I just close its properties just so I have a full screen. So I'm going to select this drawing. So I'm going to skip over the step of creating this output drawing just because it's a fairly lengthy step for generating a drawing with that many parts in it. But I mean, I could quite easily do that. I'll show you sort of the sources that produce that drawing. So I'll go ahead and create a new marine drafting here. And this brings up the wizard for going through the steps of creating a drawing. So in this case, because I selected a unit drawing, output drawing here, it's pre-selected an existing drawing, but I could say create a new one and go through the steps and just give it a nest name. And so here it would be going through. So this is the steps of creating an output drawing where I can select the sources. So I could say, oh, I want to pick all of Unit 2, or I want to pick specific areas of the ship to generate the output from. Maybe I want to specifically do a main deck arrangement drawing. I could pick a volume that encompasses the main deck. And again, I'll just not generate those just to save time here. So I'm going to pick this Unit 2 output drawing and go ahead and create a frame 47 drawing. So the most likely recommended way of using marine drafting is to actually create one view per drawing based off of one output. Again, you can end up using multiple views or layouts for one output drawing in one drawing. But the accumulation of output objects can tend to slow down the update because it's comparing geometry. I'll show you that later. And then we have a template-based system here. So like all the other ShipConstructor output drawings, we have a template that defines a layout, and the layout has a title block here with keywords and a bill of materials similar to all the other production drawings. And we also have other settings specific to marine drafting that we'll put in that drawing as well, and I'll show you sort of as we go along the settings that belong in the template. But again, you have a chance to override those settings as you go through the process. So what it's doing is it's taking that output drawing and X-referencing into a template, a copy of that template drawing, and generating a new drawing here called frame 47. And it's just going to take a couple of seconds here. So it's generated this drawing, and I've got this X reference that is the whole unit. And so it gives you an idea of if I wanted to orbit around, I could. I'm not going to do it just so it doesn't bog down my system here. And I've got, in this case, I've got a little placeholder where I'm going to put my output so that it lies within my viewport for my layout space that I'll show you in a couple seconds here. So really, this drawing has no sort of special information other than what's in a regular production drawing currently, and I'll show you going through the process. But again, you typically set up some settings in the template. So the marine drafting lies here on the production tab in the ribbon. Again, we have other ways of accessing it through menus as well. So there's a fairly limited number of commands that you really need to learn. And the main ones are this auto create views. So what this does is it will create a place for the output to reside, and then the location of what actual geometry I want to include in that, and where I'm actually going to cut a section, and how the output's going to look like. So in this case here, we've got settings for how I'm going to generate these views. So this can automatically generate one for every frame, deck, longitudinal in this drawing based off of this plate area size here. So any plate that's larger than this area, I'll create a group for it. And then I've got a bounding box depth, so 150 on each side of that location. I'll go ahead and pull in the geometry around that. And then I've got control of what layers they reside on. And again, I also have control of, okay, for a frame view, I want to look forward or I want to look aft for each one of the different view directions. And then I've got some sort of control over the actual objects that are going to be generated for position of the 2D orientation icon here. And then we've also got information about, okay, what text do I want to appear for that. In this case, I'm going to pick the location, which is the frame 47. And in this case here, I've got a location group that has the actual location of frame 47. So I can limit the generated output to just frame 47 in this case. So I don't want to see any longitudinals or decks show up, just for simplicity in this case. But if I wanted to show a deck, I could quite easily say, okay, pick marine drafting main deck. And this is location groups that you'd typically see in the hull module that are available through the utilities to actually edit the locations for those. But these are pre-set up in the ShipConstructor database, and I'll just go ahead and just use that as they are here. And then I've got some language. So what do I want to say when I'm looking forward? Do I want to say looking forward? I can change this text to be a different language, abbreviation, however you want it to show up. And that's just replaced up here with this view direction string here. And then I have layer controls and reference line information here. So in this case, for a frame view that I'm generating for frame 47, I also have reference lines that I'll generate for a baseline and for a center line. So in this case, I'm putting baseline at 0 height, and then center line at of course, y is 0. But if I had a catamaran, I could specify the half breadth of the demi-hull center line. So I'll go ahead and create a view here. And so what it does is it goes and finds the plates in the region of frame 47 and defines a box for it. And now it's just asking me to place the output wherever I want to. And in this case, I put this placeholder here so I can pick that location. And so down here in the 3D model, I've got this bounding box, which encompasses my frame 47, and it's 300 millimeters wide. So I'll get any objects within that bounding box in my view. And parts that actually travel through my box, like these pipes here, I'll show as a cross-section in the generated output. So other parts like these flanges won't show up, or this piece of equipment, all this stuff back here will not show up unless it actually crosses this bounding box. And then we also have a section plane here. So this is a plane that's defined just slightly off of or inside of the solid of frame 47. So I'll get a cross-section of the curved plates and the stiffeners that run longitudinally through that section. And then up here, I've got my actual output location. And it says, of course, frame 47, and it says looking forward, this information that I entered in that dialog. And it's got the reference lines that I have. So here's center line, and this is baseline. And so now I'm at the point where I'm ready to generate the output. So I go back to update views. And now these settings, so those settings that you saw originally in that dialog also can be saved in the template. And again, these settings can be saved in the template as well. And so it defines what information that I want to generate in my output. Do I want to see the cross sections of the stiffeners for the attached stiffeners? Do I want to see the curved plates shown with the thickness side, or do I just want to see the mold line side, single line style? Do I want to see the plate symbol, what it's going to look like, what block name it's going to use? All this information lets you control what output's generated and what layers they go on. So marine drafting is primarily a layer-controlled drawing. So the layers control the visual style of the objects, like dashed versus continuous, line weights, colors, and then you can control whether they're on or off or printed or not just by using the layer manager.
Hi, Jason. We have one typed-in question.
Sure.
Just asking if we can change the size of the selection box.
The selection box.
I think that was
yes. Yeah. So I'll just cancel that just so we can go back here. So I assume by selection box you mean this bounding box here. And so yeah, you can change the so it's by default when it's first created based off of the extents of the objects it finds in the production output drawing. But I can actually go ahead and take the grip points and say, okay, instead of 300, or at this point, okay, I see something and that I want to include, okay, go ahead and just take the grip point and move it and include more objects. Or I only want to see half of the ship, go ahead and go ahead and just take half of the ship. So it's easy to use the grip points to be able to change the bounding box size. And of course, in this case, I'm going to undo that so I get back to what I want to see in my case. But it's quite easy to do that. And again, I can orbit around and use the grip points. So the grip points is typical to AutoCAD box grip points, where I can choose to resize it or move it around however I want to move it. Same with the section plane. Again, I can move this to wherever I want the section plane to reside. But again, you have to be careful about where that is, because if I had stiffeners butting into a frame, I don't really want those cross-sectioned showing that they actually pass through my frame. So you have to be careful about that. So I'll go back into my generating views. And again, so back to the layer control here. So all the objects are sort of isolated based off of their part type. So I'll have stiffeners and faceplates. All the structure parts are sort of on different layers. And again, if you want to put them all on one layer, you can just say that these layer names are the same name. And again, I have control of all this information of where everything resides on. And again, I'll show you once it's generated here. And so it's asking me if I want to generate all views. In this case, I only have one, so I'll just do that. And so what it's doing is it's looking at that bounding box, figuring out all the parts that belong to it, and then going through a fairly complicated algorithm determining what parts need to be sectioned, what stiffeners are attached to plates, what plates are behind plates, to determine how it's going to visualize the objects in terms of, for stiffeners, a single line mode, and looking at the end cut details, and then plates, and so it's generating an output here. So we can see that we have output that looks like this, and then again, like I was saying before, this is just plain AutoCAD objects here. In this case, you can see there's quite a few just on this one side. So I just have lines, circles, points, arcs, and polylines here, mostly polylines because it tries to join up the geometry as best it can. And so you can see it's taken equipment items and done a hidden. Go ahead.
Yeah, we had a question just a minute ago. Can we create new layers from that menu box?
Yes, correct. You can create new layers in that dialog. So there's settings for generation settings. So I can go into that dialog at any time in here in the template and just tell it a different name. In this case, it's look through, and so I can call it whatever I want. It creates the layer so if the layer doesn't exist here, it will create it in the drawing. But typically that will not be the case. You'll actually go and set that information up in your template. Mm-hmm. So if I look at my layers,
we also had another question. Why no longitudinal? Yeah.
Okay.
Why no longitudinal stiffeners shown?
In this case, do I have longitudinals? Well, here's a longitudinal. You're talking about a specific problem? In this case, I don't think there's many in this one, is there? It's not really. There's a couple down here. And so, again, the output is straight AutoCAD objects, except for the reference lines that you'd seen when we created the view. And again, these objects are quite smart. They don't allow you to stretch them around to move the locations of objects. So you're not going to hand you can see I can move it up and down, but not side to side. So I can't ever get the half breadths being in the wrong location. So it says it's one thing, but it's in the wrong location.
Steve clarified his question. His plate stiffeners. He sees punch outs, but no stiffener section.
I assume that's other languages. Yes, you can use other languages. Again, we give you the option of changing the strings from looking forward to whatever language you want. Again, this information here comes from location group. So there is nothing that is English specific other than the stuff that's in the dialogues currently. So all the actual output is generated can be any language that you choose. As far as the stiffeners, are you referring to a specific problem? There was a problem prior that was fixed where there were places where stiffeners weren't included. Oh, the menus. The menus are currently, from the ShipConstructor point of view, are currently only in English.
I've enabled Steve's microphone if you want to ask the question, Steve.
Oh, okay. No, I just, typical cross-section drawing, I'd expect to see the deck stiffeners and side stiffeners and bottom stiffeners. Are they just not in the model, or are they?
Yeah, in this case, it's not. I'd have to go to a different model. So this is just I don't know if I've got a frame. I have to maybe go to another frame that has that. And yeah, in this case, this is just the way that the ship is. The structure of the ship doesn't have shell stringers or deck stringers in this specific location. Let's just zoom down here a bit here. Yeah, I don't see there's a lot of longitudinal structure in that other than, so it's mainly based through plates and transverse structure too. Yeah, it's just this model's design in this specific case where it's, but those show up as you would expect.
Okay, that answers your question.
And another question: how do I hide the piping joints? Okay, so pipe connections. So you can see the pipe connections here. I'm not sure. Some of these are, of course, in this case, it's a simple one where it's a butt joint, but I have other details here where I maybe want to simplify it, or like this case here where I've got a coupling and it looks more complicated than I'd want to visualize it. At this point, we don't have a way of automatically reducing that information out of that area. It takes the information from the solid and uses that information to generate a hidden line removal of that view. That's currently the only way that we currently do it. So there is, so I can hide elements in this case of the hidden lines of that, but again, it would also get missing this hidden line of this pipe as well. So currently, there's no easy way because it's not a separate item to separate that. So it's something we're in the thinking about being able to handle, to be able to handle pipe arrangement drawing output more smoothly, but it's one of the limitations currently.
Jesus, I've enabled your microphone.
Let me get back.
We had a couple of questions from Jesus. If you'd like to speak up. Perhaps he's having audio difficulties. Okay, continue.
Yeah, I think Jesus was asking for the menus to be, are they English only? And yes, that's the case currently. So there's all the ribbons from ShipConstructor are currently only English-based ribbon and menus. But all the AutoCAD elements, you can use an AutoCAD based off of another language, and you get all the AutoCAD elements that are in the other language. So getting back on track here, let me just get back to my position here. So I have my output, and again, I was showing you that, again, all these output objects are just plain AutoCAD objects. So here I have a polyline, but again, ShipConstructor attaches some smart information to it to know information about what part actually this came from. So it knew this line came from this faceplate called SSIO2 or whatever. And same with this, so it knows essentially any output object where it comes from and what's all the information about it. And then I can go in at this point and detail the output. So if I just switch over to layout here, you can see now I have a fairly typical drawing where I've got a title block and a border, and I've got a view. And again, I can either set this up to be a view at a specific scale, or I can just zoom extents and have it not to scale. And then we have typical output for our production drawings where we've got keywords that are updated automatically here when the drawing was created. And then I've got a bill of materials that I'll go ahead and update. So in this case, it's a fairly simplified one that just shows the stocks. And then I can use that information to generate labels. So here, just so you can see what stocks are available here. Let's close this to get a little more real estate here. And then I can go ahead and detail this drawing. But typically, because of the number of objects, number of parts in my actual output, automatic labeling would be, at this point, it's currently a bit unwieldy in terms of the number of objects it creates. So it's recommended to more manual labeling in this case. So where I can pick individual parts. Pick here and say, so I've got, it's pulling out the stock names for these, and I can pull out this stock here, whatever details I want to pull out as labels.
We've got a couple of questions in the queue,
Okay.
Jason.
Sure.
First of all, Tommy has asked about pipe again. Pipe that is joined, show the connections. How are these hidden? Do you see that? It's a text submission.
Yes, like I was saying before. So like I was saying, this connection here. In this case, this is a piece of an equipment item that's connecting the pipes here. So it's an atypical pipe connection per se. But again, it shows you information. Or here I have got a valve where it shows the connection, so I can see probably more detail than I may want to show, like of course the actual hidden lines for the ends of these pipes here, which I may not want to show. But like I'm saying, I mean, the only way to not show those is to be able to do something like that and erase those objects currently. But again, I have control of what is that there and shown. And this sort of points that you have here are shown for the connection. So if I wanted to show actual accessory package details, I would be picking those connection points, which are just points in AutoCAD. So there's a way of actually being able to show the connection accessories in a bill of material and have them labeled here if I really wanted to. So that's why it's showing those. It's one of the output options I have.
Can we? Can the BOM pull other parts other than structure?
Yeah, of course. The bill of material is just like any other bill of material in ShipConstructor, so it's not structure based at all. It's any collectors that you choose to add. In this case, it was just a structure collector, but again, there's no reason you couldn't choose an equipment collector, a spool collector, or a pipe part or an HVAC part collector. All the regular collectors you have in any arrangement drawings or assembly drawings are available in this drawing. And so you could be able to label those parts instead of structure. So if I wanted a piping arrangement drawing, I could quite easily not label the structure and label the pipes.
We have a question from Jose. Jose, go ahead.
Yeah, I have a question. Before you, I noticed when he dropped the 2D view, everything was in a white color. Do you have the ability to determine or tell ShipConstructor which layers you want certain objects in, like stiffeners a certain color, brackets a different layer?
To some extent, yes. So if I go here into the layer control, I have stiffeners. So if I want the visible stiffener, so stiffeners come in too. So I have the hidden stiffener lines, which are the dashed, well, the flange line is a separate layer as well. But if I want visible stiffeners, I can say, okay, go ahead and change that to, I don't know, some other color. And now you'll see the stiffeners go ahead and change color. Of course, AutoCAD.
Okay, very good. Thank you.
So there's my stiffeners as a different color. But by default, it's just when it creates the layers, it just picks a default color. Again, all this layer control for setting up the line types and the layers, so it's picked the dash lines for these hidden layers. Again, you have total control of the line type, line weights, colors, all that information, whether they're visible or not. And so all this layer control is completely controlled by you. So if I don't want to see any of the piping information, or I want to put the piping information as a lighted color so it's not so emphasized in this drawing, I can quite easily do that based off of the layer manager here. And again, those settings you just set up in your template, and when you generate your drawing, you don't have to worry about that information. It's automatically set up to that style. And of course, I can come in here and as well do dimensioning, so I can go ahead and dimension. So if I go over here and go to annotate, so just again, this is just AutoCAD stuff at this point, so it's just dimensioning, output, I want stiffener spacing, and again, that's quite easy to do that sort of stuff in this drawing. because you have just plain AutoCAD objects at this point. Let me just see what else I wanted to talk about. Oh yeah, so again, we also have generated output like these weld symbols. We have the intercostal and continuous symbols. Again, those are things that I can change at any point. So if I wanted to go ahead and say, oh, my definition is, so I've defined this using a block. And this is the default implementation. So if you don't have this block, it will automatically create the standard symbol. But again, you can have a different symbol if you prefer. And again, I can go ahead and just quickly edit that if I wanted to. And change that if I choose. So if I want to have it, I'm just going to draw another whatever lines. And then now you'll see that all the weld symbols look like this now. And again, you have the choice over the size based off of either that, or there's also a sizing option in the settings. So now you can see it's now updated. And so a lot of this output, again, is not available through regular ShipConstructor. To put in these weld symbols yourselves manually in ShipConstructor, it would be quite a lot of work. In this case, you can see there's some cases where you see symbols where you probably wouldn't want them, like in this case up here. It's just taking a while to regenerate here because of that updated block. Is it done yet? No, it's still thinking. Come back.
There are a couple of questions in the text queue.
But I can erase. Okay. Can you assign a thickness throw symbol? I don't know if that's the first one. Let's go. Does ShipConstructor support 3D printing? I guess that's a bit off topic. 3D printing, I would say yes, actually, but it would do through an output drawing. So you can take one of the ShipConstructor drawings and generate a solid model from it. And from that solid model, you can create a 3D printed, although I haven't done any 3D printing specifically. But it's just you can create a 3D solid model from ShipConstructor. Whether it would be, I'm not sure, I can't say that I've done it, but I can't see why it couldn't be done. Getting behind here in them. I don't have. Can we modify end-cut symbols for stiffeners? Yes. So my AutoCAD 8 coming back. Oh, there we go. So yeah, like I was saying, if there's cases where you have, it's sort of getting me back on what I was talking about here. Oops, yeah. So there's cases where you would not want symbols, and again, anything that I erase now will not come back when I generate the view again.
Can we modify the end cut symbols for stiffeners?
Yeah. So
yes.
So the end cut symbols for stiffeners. I'm not sure why my mouse is not coming back here. Show as, in this case, they show as a simple perpendicular line, and the end cuts are based off of the names of the end cuts. So if I look at the block list, I'm not sure if this one has any specifically, A12. So this is an end cut name in my end cut catalog. And so I can, again, edit this block and change the definition of what it looks like. So if it's a snipe, then I can say draw a line at an angle, and it will go ahead and show a snipe end cut. and that information can come through. So again, it's one of those things where you define the blocks in the template for every one of your end cuts, and it'll go ahead and use whatever the end cut definition for that one is for each one of the stiffeners. So yes, you can replace those. Starting to stack up here.
Yes, a lot of questions. Please be patient. We get another question. Can we manually update the labels and add, say, bracket size or web girder size? That's from Dimitri.
Yeah, I mean, this isn't specifically I mean, this is an AutoCAD drawing at this point, so you can just do whatever you want. There's other information here. Let's get back on where I've got property labels. So property labels are just another method of generating labels. And again, I'm not sure why my mouse has gone, cursor's gone. So I can generate information from that part. So it looks at all the part properties for that. So if I wanted to have a user-defined attribute, a finish, whatever information that I wanted to show for, maybe I wanted to show the weight of that part, and I could say, oh, yeah, weight. And I can generate a label for that. But again, this is just the output here. So I've got the weight showing up for that stiffener quite easily. And let's go, what other? But the bracket size, so the bracket size either could be encoded in the stock name of the standard part, or I could, yeah, but typically that's probably where you'd have it for that. But again, I could add your own labels at this point in AutoCAD as well. Is MD drawings in ShipConstructor 24 compatible with ShipConstructor 20? Will they work after upgrade? Yes. Anything that we have in ShipConstructor, upgrading works with them. So, you know, upgrading your model always essentially supports upgrading of the objects. And marine drafting is in a sense is more simplistic than the modeling side of ShipConstructor because it's just simple AutoCAD objects. So there's not really there's not much risk of having any problems anyway. Update the production drawing. Okay, so yeah, I'm going to show you updating the model. Will it work with all Autodesk product line? Okay, you can take that offline. But most, I don't think we've certified every one of them, but there's definitely a lot of them that we've gone through testing and certified. How to generate an arbitrary view. So yeah, in this case here, or of course the main views are the primary views. But if my plate part was skewed in any way, I can generate a view from that as well. So it's quite easy to generate one for any of the skewed directions. And again, it sort of automatically handles it based off of the orientation of a plate part. But again, I can also theoretically rotate my view as well. But you don't really want to get into actually rotating the bounding box in the section, but it is possible. So now I'm going to go into and showing you the update part of it. So I can take an object here, just an AutoCAD object. Let's pick one here, and say go to model drawing. So again, this is just a polyline AutoCAD, and it's got this special command that says go to model drawing. So it knows what drawing it came from. Yeah, sure, I'll save this drawing. So what it's going to do now is it's actually going to go to the structure model drawing that part belongs to, which is the frame 47. And I'll go ahead and change one of the parts. And I can change the stock as well. There's other information that essentially any information that you change here will propagate its way down into the production drawings through our update drawing process that I'll show you here. The auxiliary view.
Can we assign a thickness throw symbol?
Oh yeah, the thickness throw symbol, currently we don't have the thickness throw symbol for plate throw directions. It's one of the things that we haven't added currently. So I have my part here. I can add a hole to that part. Let's put it down. I'm not sure why my mouse is not. Somehow my graphics got in a case where I've got my mouse missing. But I'll go ahead and add this hole to this part. So this is the modeling commands here. Where it's adding this hole to this part. So now I have a hole in that part, and I can go ahead and as well, I'll go ahead and change the thickness of the part. So I'll change it from 11 to 12. And of course that also changes the faceplate that's riding on top of it, its location. So I'll go ahead and save that. And then go to, in this case I'm not going to go back to that specific drawing just because because there's so many parts in it, I'm just going to, for speed reasons, I'm going to go ahead and update a similar one here. So I've got a similar one that I've created. So here I have a similar drawing with the frame 47, and I'll go ahead and update this drawing. So you can see that it doesn't have the hole in it, and the thickness still says PL11. And so what it's doing now is it's going back into the ShipConstructor database, getting all the latest parts, updating the output drawing that was used to generate this drawing, and then updating that drawing, and then updating this MarineDrafting view. So right now it's updating the output drawing. And one of the recommended ways of doing it is, so it's updating the UO2 drawing, so any drawings that are generated from it can more easily be updated, because once it's updated, then that single part can be updated in multiple MarineDrafting drawings fairly easily. Whereas if I had a pipe arrangement drawing and I had a part in it, I'd have to go to each pipe arrangement drawing and update those, in essentially updating that part in several drawings multiple times. So you can see now here it's automatically updated it to PL12, and I've got my cutout in it. And if I was someone that wasn't the person that actually made the change, I say, well, how do I know what's changed in this drawing since I first created it or first had a revision? So I'll go ahead and look at the revisions for this drawing. And I can see, oh yeah, this person, Jason, updated this drawing. When did he update the drawing? So I can see, okay, he updated it this morning. And I can see the whole history of this production drawing when it was updated. Who created it? When did they create views? When did they delete parts? All the information about this drawing is available. And I can also look at what parts got changed. So I can see when I updated this drawing that these two parts got changed. And what happened? They're not new parts, they're just modified parts. So if new parts came in, I would see those as well. And I can also visualize this in the output. So I can see by color coding, that the more modified stuff is blue now. So if I zoom out here, I can see, oh, okay, this stuff is the stuff that's changed. So I can quite easily know and go in, and if my dimensions need or notification notes that I have here need to change, I can quite easily go and inspect what things need to be added or removed or changed quite easily. And I can also zoom and highlight, so I can actually go and say, oh, I want to go and highlight the parts that, so I want to highlight a faceplate in my frame 47, and I can see, oh, that's that piece there. Or I want to look at that plate part, oh, it's that piece there.
So the demonstration, demonstration right now shows sort of a hull section. One of the questions we have is in the bow section, to show the structure. How will the shell plating be represented in the bow?
Yeah, so let's. So we're getting into the sort of the limitations. So I've had a lot of queries about how curved plates are hidden. So you can see that curved plates show up here as a section. So that's currently the only way that they show up is as a section by the section plane. So like in your scenario here, where we want to see essentially the curvature, or I want to see the bow plates, they will only show up as a cross section. So if you had a view where you wanted to see like the trace of the edge of the plate, you wouldn't be able to see that currently. Again, that's one of the features that we want to work on fairly soon, but that is a limitation of one, the complexity of the curved plates. So the processing time for those would be fairly long in terms of generating a hidden line removal drawing. And as well, because of the number of faceted faces on it, the output would be fairly more detailed, or have a lot of more junk than you'd want to have in that view. So there are some still technical hurdles we need to go through to be able to properly show those, but there are some tricks that we have in mind to be able to at least show the outlines of those as well. How shall plate represented? But there's a way to know what has changed on the part. So no, I don't know. So I can see the geometry, but I don't know necessarily what specifically has changed, other than I know the complete. So anything associated with a part will be marked as modified. So I don't know if I added this specific circle. But at least it gets you to the details where you can get into that information. Some of the information you can sort of see what's changed based off of some of the information. Again, there's some information you can get from the revisions, the more detailed part revisions. In this case, it only shows the last revision that the part undertook. So the specifics of what changed, whether I changed stock or length of it or add green or what information was added, I don't have that currently available here. But again, that information is available through the revision dialog. That log will have to be kept outside ShipConstructor, right? Well, ShipConstructor does track some of the changes, but not details. Like, it doesn't know I added a hole. It knows I added an object, but it doesn't know it is necessarily a hole. It could be a line that trims the part. So, or if I add a cutout. Some of this information we don't have to that level of detail, but it knows some of the information that's changed. But if I change the throw direction and not the plate stock, it doesn't know the difference between those. Comments for these revisions? No, this is all automatically generated. So there are some comments, so like the details. So revisions, that are shown here are not only so we have revisions to this drawing which are changes to this drawing, but we also have revisions in terms of managed revisions in ShipConstructor where I want to say, oh, this is revision A of this drawing, and it locks down the bill of materials. And that information can have a description, and that information will be shown here as well as under the description part of the, under the details of that actual revision. So revision, it'll show revision A created with the actual description you called revision A. Is there any way to see how the part was before the revision? Currently, you'd have to so if I undid, yeah, currently you don't see that information in a view here. But I mean, there's no way I can sort of overlay it currently. That information, well, there is, but it's not a recommended way of doing it. But you can essentially not erase the stuff that was there originally. But it's not, like I say, you'll end up with more problems than not. For interior assembly drawings, we need to X-reference several frames. Is it possible without X-referencing the whole outfit drawing? Okay, so for interior drawings, okay, so Lambertus's question is, I assume that he wants to have a drawing that contains information that's not necessarily the whole ship, but to simplify it. So we currently limit marine drafting drawings to X-reference in only one output drawing. And you decide what's going to belong into the output drawing. So the output drawing can be the whole unit, or it can be just a single part if you want, or a single frame. But you cannot use M-link model links to add extra XREFs to this. You can do that in an assembly drawing, though. So if I had an assembly drawing that represented a specific assembly, I can M-link in other reference materials that I want to have in that drawing, and those will show up in the marine drafting view. I can also use part views as well. So the part view component of ShipConstructor lets me bring in parts in an area or related into any output drawing or model drawing. It can use that information and put that in the marine drafting drawing. Can we set up an extra viewport in marine drafting? So marine drafting is primarily for single 2D views because of the way that the model looks like. So if yes, you can set up an isometric view, but I wouldn't really want to set up an isometric view of this model just because it's more of a work. That could be the case in an assembly drawing, yes. So in an assembly drawing, you can create marine drafting views quite easily and have that side by side with an isometric assembly. So I can have both an isometric and in this case a body view. But I wouldn't necessarily do it in necessarily an output drawing just because of the way that the objects in the output drawing are, and you can't sort of select. Yeah, you can do it for these, but I wouldn't say that that's the primary purpose. I would probably do that in an arrangement in assembly or arrangement drawing. Mark in time with Navisworks should show this Mark in time with Navisworks should show this info revision history. Okay, so I'm guessing you want to show that revision history in Navisworks. That's, Tommy, is that what you're asking? I'm not sure if we can show that. Oh, I mean, so Lambertus, I mean output drawing instead of outfit.
No, I
Yes,
believe you covered
okay.
that, actually. Yeah.
Could you
Kent has
please
a
go through
question.
the setup of the reference lines? Okay.
Yeah.
So it's reference lines in the template. Okay. So the reference lines were created with MarineDrafting. Like I say, they're not specific to MarineDrafting. Again, I can set those up in a template. So I'll just go ahead and create a new MarineDrafting template. So whatever. Just. So this is just going to be a blank drawing. Yeah, go ahead and save that just so if we want to return there. So I've got an empty AutoCAD drawing. It's got nothing in it. I can create reference lines through the reference line manager. So the reference lines are designed to be similar to the way AutoCAD works. So I've got a manager that has a current style and I have properties. So just like dimensions or text, I have a current and I can say modify styles and I want to make a new one. It bases off the current one. So and by default it creates a standard one. So what you'd expect when you see AutoCAD. So I can either modify or create a new one. So it makes a new one based off of standard frame center line. So I can create these manually myself. So I can go ahead and say, okay, I want to have it with the tick line centered and, you know, all this different settings here. Okay, I want to take for the frame center line, it's going to show water lines and, oh, I want to show whatever water lines. So the frame center, but I don't want it to say baseline, or I want it to say center line, whatever. In this case, so you can actually have the CL symbol based off of a different text font, but I'll just simplify it here. And again, you can put it at the top or at the bottom. All these sort of different things. Okay, I want to have a different color. Yeah, all those sorts of different things you have options of. And I can also, if I've got those, so that just creates a style now that's in this drawing, and it's just stored in this drawing. And I'll have that available for when I'm generating my redrafting, or if I create a reference line here in this drawing. But again, I can also import ones from another drawing. So if I want to import them from, oops, that's a bug. If I want to import those from a different drawing, I can do it.
So we got one
So,
question
yeah,
here. I think
some of the things I can't do in the template.
Pretty core aspect. Can we support ShipConstructor MarineDrafting drawing to regular AutoCAD drawing so there's no links to ShipConstructor, no XREFs, and all objects become regular AutoCAD objects?
Yeah, so the ShipConstructor export allows you to have those drawings, but they won't be linked per se. So if I go back to my MarineDrafting drawing, let's just open this one up. No. So so when I've got this drawing here, it's got links to, so the actual XREF is not so important. It's only important for the case where I've got AutoCAD fields, which are our property labels. So the field actually references the object in the actual output drawing itself. And so if I deleted this XREF, then that would become the missing field symbol. So when I generate, so when I export this under utilities, no bracket, export DWG. So I see export DWG. So when I export the DWG here, it has information about how I'm going to see stuff, but in MarineDrafting this is pretty much not relevant. So what it'll do, it'll actually get rid of that X reference in this case, and then you'll explode the reference lines to get the details for the reference lines as just AutoCAD. So again, this is for any ShipConstructor drawing, this is essentially a way of creating a drawing that's just plain AutoCAD. But again, there is no link between that drawing and this drawing. So if I update the model, it's not going to propagate to that drawing unless I export the drawing again. And again, there's tools with the enterprise platform to be able to automate some of that stuff. I just didn't go through that because there's no reason to. Where are we here?
One question is, can they generate drawings with several views, or does it need to be done one by one?
Yes. So the one, yes, you can generate a drawing with several views. I limited in this case to one view, just so I can concentrate on one. But when I create a view, and go ahead and create views, I can specify. In this case, there's some bit of a trick of the way. So there's ways of setting up through the locations or position. So in this case, it's specified this location keyword. So it's going to look at the locations based off of these items here. And so if I just said position here, and now what it'll do is it'll give me every deck. It will, so you can see it's grayed this out, so it doesn't care about the locations for decks. And so now it will go and find any deck plate that's larger than this 1 square meter and create a group for that. So hopefully so there you can see it's generated a bunch of decks and skewed decks. So you can see some of them are skewed, so you can see some of the center lines here are actually in a skewed angle. So it's actually done the canted decks in this case. And the names of them are just based off of the locations of where the elevations in this case. And because they're skewed, they're somewhat really strange numbers. But I can go ahead and generate output for that and say update. Of course, getting off of the actual subject of it. Okay, we're getting down in time. And I'm just generating one just so you don't have to see me generate all of them here. But again, I've never done this one before, so I don't know what the output's going to look like. So hopefully it looks good. Is there any ones I've missed? Can you open the XREF manager? Is the output drawing an XREF in this? Yes, so the output drawing is an XREF, but not an MLink. So yes, the XREF manager, the regular AutoCAD XReference, that's all this output. The drawing is in this drawing. So it's specially known as the source of this drawing. But you would see it in that. I'm not sure why this is taking so long. Being skewed direction, maybe it's. Is there any other questions? So that's primarily what I wanted to show you. If there's any questions that you want me to quickly show, I'm not sure if when it was to sit there and wait for this, I'm not sure why it's taking so long though. But instead of waiting for this, I can, oh, there we go. In this case, it looks a bit skewed. So because it goes through a bunch of frames, so in this case, it looks quite strange. Basically, it's going through the whole hull, but it may represent a single plate. I'm not sure what area this is dealing with. But again, there's the output. So yes, the webinar will be available, so you can replay this again if you prefer.
Do you have time
I'll
to
pass it back to.
do you have time to show an auxiliary
Mark.
view creation?
Well, what do you mean by auxiliary view?
Well, Tommy had a couple of
Yeah,
questions.
I don't know.
We can take
Yeah,
them
what do you
offline, and yeah, probably best. We will need to start wrapping this up. So
yes.
we have your questions. If you're a subscriber to SSI ShipConstructor Client Care, please send them via that path. That would be great. If not, you can send them to product.management@ssi-corporate.com, and we will be happy to dig into your question and answer it. If you want to hand it over to me, that would be great.
Sure, I'll hand it back over to Norm.
I just get the right screen this time. Yes, okay, good. So just a couple slides to wrap up. Where's MarineDrafting available? It's been available since ShipConstructor 2014, and each release we enhance it, of course. There's the product editions. You're aware of, we have simplified the structure into 3 standard, premium, and ultimate in terms of parts. My mouse is going crazy. We also include suites now, so you want to take a look at ShipConstructor suites and see what's in those. In the ShipConstructor suites, the parts are unlimited. Basically, suites are intended for small to medium-sized firms with medium to large projects, just as a general rule of thumb. One thing we want to make sure you take away from this session is that it's not just for class approval drawings. It's really useful for many other aspects, and we're getting a lot of inquiries in terms of expanding this capability for not just marine drafting but other aspects as well. So if you have any further questions, I encourage you to send them to us. One thing I'd like to highlight in conclusion is this is part of an overall series of webinars that we are presenting. So every 2-3 weeks or so, we will be publishing, we'll be doing a seminar similar to this for different aspects of the products. The next webinar is October 15th, and it's going to be going over our Publisher LT product, a brand new product. And that's everything for today. So if we don't have any more questions, or we can, do you have any more that we can answer right now, Jason? Or?
Yeah, so it says, can we put, I assume that, can we put name on equipment for a GA or machinery arrangement? And that's yes. So you can either show, so you can create a bill of materials that shows the equipment stock or a tag number, and create labels automatically for those using an equipment collector in a bill of materials. So that's quite easy to do. Or again, you can use the property labels as well if you want to show. So there's sort of 2 ways of labeling things if you didn't want to bill of materials. But typically you'd create a bill of materials with what you'd want to label for equipment and show that information. So yes, that's quite easy to do.
So I had a question here, 2 things. We will be saving the recording of this and making that available. Just have to do some processing. I'll probably fix the intro slide. And encourage you to go to Augie Marine Forum to discuss the general topics and everything. This is something that AutoCAD has helped set up, and we encourage you to use it. We'd like to see lots of chat there, general industry, not ShipConstructor specific. So if there's no further questions, I guess we can conclude.
So, yeah, so how do I ask a question after this ends?
Oh, okay. Well, when we publish the video, first of all, you will be notified, and by GoTo, and you'll be able to go there and review the video from there. In terms of the questions, how do I ask you a question after this ends? Again, if you are a subscriber, log into your Nexus account, submit it via that. Otherwise, send it to the product.management@ssi-corporate.com. And if you want a general discussion, that's what the Augie Marine Forum is for. You can throw out the question there. We'll be happy to respond there, but others can also assist and provide you with answers there. That's the benefit of the forum. I hope that's everything. And as I said before, the video will be, you'll be notified. It'll be downloadable from viewable from the go-to. I'll probably publish that tomorrow after we do some post-processing. So thank you, everyone. Thank you for your time. I hope you found it useful, and feel free to follow it up. Oh, Tommy's got one piping question. Go ahead. We've got 5 more minutes till 9:30. So if you'd like to ask, go ahead.
You can turn on his mic if you want.
Yeah, maybe I'll just go look for it here. So,
in the view.
yes, there you go.
So in the marine drafting, I was hoping to see that those would not show up, because when you export to a 2D drawing, they show up. There's no real way to get rid of those, and they look like fittings. It's very confusing to the
Can you start again? I didn't get the beginning of that, Tommy.
Can you hear me?
Yeah, I can hear you. Can you start at the beginning again?
Sure. Yeah. On pipe bending, the bend point joints, they look like elbows. Is there a way to eliminate those? Because they look like fittings.
Let me just open that up again. I'm not sure it's going to be. 47. So which view you're? So when you're looking where you can actually see the bend of the elbow?
If there's a bend in that view, the joints where they come together, they look like fittings. And in a representation on the drawing, those points, there wouldn't be any lines there at the tangent point from the bend to the actual pipe. The bend point, not the bend point, but the joint. Do you see a line there? It looks like a fitting.
Well, essentially it's doing a hidden line removal of that object. So
you see those bends right there? That's
okay, I see what you're saying.
Right there
yes.
would not be shown in the piping drawing.
Right.
And if you delete those and you update, do they come back?
No, they won't come up. So if I update this drawing now, it won't come back.
So that's my question. It requires manual editing, but still you'll be able to get rid of them. They're just dumb lines.
Correct.
There's no way to process this out to know what's fitting and what's pipe and to hide this stuff before as you extract it or as you process this marine drawing.
Sure. I guess that's something we had noticed as an artifact that we want to remove.
Yeah, just don't want to bring that up because the users are asking this, and it was a problem when they did an export. It comes over as solid models, and that information that they're trying to use is not an easy way for them to get rid of that. Right. And they asked me to ask that question today.
Okay,
so that's my main thing about the piping for them is that joint, when it's a bend, whether it's a 90 degree or 45 or whatever, it actually looks like a fitting.
Correct.
So anyway, I asked my question, and it's not available yet, so maybe this would be something we put in there on a wish list?
Yeah, no, you just put it on a wish list, so.
Okay, good. All right. That's all I was interested in, but you see my point, right? They look like fittings.
Correct. Yes, you're correct. They do look like fittings, and they both look like butts. Yes.
Thank you for that. This has been a great presentation.
Thanks for attending, Tommy.
All right. Bye-bye.
Bye.
So, okay, if we're done, so I believe it's 9:30 now. So thank you, everyone.
Muted. Unmuted.
Have a good day.
Okay.